Now, about 200 million years after the Big Bang, the universe was filled with these large, hot, massive stars. They glowed so brightly that they created pockets of warm ionized hydrogen in their vicinity. Because the first stars were so massive, they did not live long, after only a few million years. They exhausted their hydrogen fuel and went supernova. But before they blew up, these massive stars were surrounded by disks of material that collected into bodies of rock and dust called planetesimals. Some of these objects survived the supernova explosion and became the building blocks of the first rocky planets. So it seems that the first stars were too massive to host planets ourselves. We know that our solar system is special. We just don't know yet how special. However, the more we learn about other systems, the better chance we have of understanding how and why our solar system formed. Scientists are looking for these objects called population 3 stars. Remnants of the first stars. One possible candidate is HE 1500620, with only 1/5 the mass of our Sun. It may be the lightest member of the population 3. The big question is whether the abundance of molecular hydrogen was so low in the early universe that population 3 stars like HE 1500620 were unable to ignite and form. But that idea doesn't fit with the observation that molecular hydrogen is surprisingly abundant around young stars today. So the first stars may not have been as massive as we thought. 2 studies have addressed this issue. One study used a new astrophysical computer simulation that models turbulence within the cloud, causing fragmentation into smaller clumps of gas that collapse into lower mass stars. The other study, an independent laboratory experiment, demonstrates how molecular hydrogen may have formed earlier and in larger abundances than previously thought. And there is a lot at stake here because the story does not end with the first stars. There is a period between the Big Bang and the formation of the first stars during which the universe was filled with a sea of protons and neutrons. Within this primordial soup, atomic nuclei combined to form the first molecules. That era is called cosmic alchemy. This is the period when the universe went from a soup of elementary particles to a place with complex molecules flying around. In this context, molecular hydrogen is one of the simplest molecules. Another critical molecule is ammonia, NH3, which is a molecule of nitrogen and hydrogen. Both molecular hydrogen and ammonia are critical ingredients for star and planet formation. In fact, there is a good chance that planets would not exist without them. Indeed, planetary systems tend to form in thin disks of gas and dust that surround young stars. Astronomers do not fully understand how these disks form, but molecular hydrogen plays a key role in allowing the gas to cool down to the temperatures required for condensation. Molecular hydrogen is also important for life as we know it. Water, a key ingredient for life, is simply H2O. Stars form out of collapsing gas clouds, and planets form out of disks of gas around those stars. Without molecular hydrogen, star and planet formation as we know it could not occur. For decades, astronomers assumed that the first stars formed in cold, dense gas clouds. But recent research suggests that the first stars may have formed in relatively warm gas. Provided that molecular hydrogen was sufficiently abundant, the big question is how did molecular hydrogen get that abundance? An international team led by Dr. Maria Colleoni at the Argelander Institute for Astronomy at Bonn University in Germany carried out experiments to find out. They wanted to simulate conditions in the early universe to determine how molecular hydrogen could form under various extreme conditions. They took molecular hydrogen's building blocks, hydrogen atoms, and smashed them together using a particle accelerator at the GSI Helmholtz Center in Germany. Their goal was to recreate the extreme temperatures and pressures found in giant gas clouds in the early stages of star formation. Drive Colleen and her team recreated the conditions of the early universe using two beams of hydrogen atoms accelerated to 1/10 the speed of light and collided them together. The experiment revealed that molecular hydrogen forms readily under such conditions. Interestingly, the team found that the reaction is catalyzed by a grain of iron or nickel, which is an important ingredient for the first stars. Iron and nickel are among the first elements forged inside massive stars and released into the universe when those stars go supernova. The abundance of iron in the early universe may have played a crucial role in triggering star formation and the subsequent enrichment of matter with heavier elements. Although the experiment demonstrated that molecular hydrogen can form under extreme conditions, it cannot tell us if it can survive. Further theoretical work is needed to confirm whether molecular hydrogen would remain abundant enough for star formation in the early universe. The researchers have shared their results with the scientific community through publications in prestigious journals such as Physical Review Letters and Astronomy and Astrophysics. The former study proposes that turbulence in the early universe could have fragmented the large gas clouds into smaller pieces, each of which could collapse into a lower mass star. This fragmentation resulted in a distribution of star masses with a high fraction of low-mass stars. The latter study demonstrates how molecular hydrogen can form under extreme conditions such as those found in the early universe. The researchers found that the reaction is catalyzed by iron grains, which were likely abundant in the early universe due to the previous generation of massive stars going supernova. Together, these two studies shed new light on the conditions and processes that may have led to the formation of the first stars and planets. More research is needed to confirm these findings and to further our understanding of the early universe. However, these studies provide an exciting glimpse into the conditions that may have led to the formation of our solar system and other planetary systems in the universe. I hope you enjoy this video. Please subscribe and follow for more updates on astronomy and astrophysics. Thanks for watching. See you next time.